everybody, in this video we're going to talk about a special type of right triangle known as a 45-45-90. So let's start off on the left side of our screen right here looking at this square. So what are some properties of a square? We know it has 4 right angles and we know that all 4 sides are the same measure. So for the purposes of us proving the side lengths of this 45-45-90 right triangle, let's say that each side of our triangle is just 1 unit, okay? So now each side of our square. So now let's split this square into 2 triangles by drawing this diagonal segment right here. Okay, so now look what it tells us. Our 2 legs of our right triangle are equal to 1, or they're equal to the same thing. So now we can transfer this over to our right triangle on the right side of our screen, and let's just use the variable x. So whatever we would have given our square there, what if we said each side is 6 units long? Well, then x would be 6, right? Each of our legs of our right triangle would be 6. So that's one thing that we can infer right off the bat. But now what about the hypotenuse? Well, if we think about the Pythagorean theorem and how that works, and we've done a video on that, I'll link it in the cards right now. We could take a squared plus b squared, and that is supposed to be equal to c squared, right? Or the legs added together, the legs squared added together is equal to the square of the hypotenuse. So now a is 1, so 1 squared plus 1 squared equals c squared. Well, 1 squared is 1, so now we get 2 is equal to c squared, and to solve for that we would take the square root of both sides. So that means c is equal to the square root of 2. So now our hypotenuse, like our general equation or our general triangle that we see on the right side here, we would say our hypotenuse is just the leg times the square root of 2. And so this is where our side measures or our side lengths come from for our 45-45-90. The 2 legs are x, so whatever we're working with there, they're just the same, okay? And a good reminder is they're both opposite of the same measured angle, so they're gonna have the same side measure as well. And our hypotenuse is just root 2 times whatever our legs were. So let's look at a couple examples where we use this information. So examples for this, we're just going to find the value of x. Okay, so we left off our x on example 1, but there we go. So we are given the legs of this right triangle, and also we need to know that this is 45 degrees. So we'll add that in there. Same thing for our triangle over here. All right, and so now we have 2 legs that have 17, a measure of 17, okay? So we know that our hypotenuse is equal to the legs times the square root of 2. So this is just equal to, so we'll call hypotenuse as x, and our leg is 17, so times the square root of 2. And so now we could just write that all together and just say the hypotenuse is equal to 17 root 2, and that is it. So now let's take a look at number 2. Now we are given the hypotenuse, and it is 6 root 2. So we can say the hypotenuse is equal to our leg, or the measure of the leg, times the square root of 2. And our hypotenuse, we can plug in 6 root 2. Leg is x. And now to solve this for x, we can divide both sides by root 2. All right, and now look what happens. We do 6 root 2 divided by root 2, and that cancels each other out. And so all we are left with is x is equal to 6. Okay, and so that is how we can find missing legs or missing hypotenuse for a 45-45 special right triangle.